All right. So guys, the goals that we have for this week. Okay. So first, we can simplify expressions using the index law for raising powers. Okay. So we have learned a few index laws last week, and um, this week we are just learning one more index law here, and this is for raising powers. So this is still part of year 8, and our second learning goal is that we can expand single brackets and double brackets. Okay, now we actually have done single brackets. Okay, so that's part of year 8 as well. But the double brackets, that's where it's going into the extension. Okay, now even though the work I'm asking you to do for the second learning goal is from the year 10 textbook, this is actually a year 9 level of work. Okay, so don't stress, and as long as you follow the steps, you would be able to do it. Okay, so our APK here, just just to get you thinking. Okay, just for a bit of fun here. Um, how many ping pong balls would be able to fit in the room you are sitting right now? Okay, so 2 minutes, have a think about it. All right, so Nam said he's in the dining room. Okay, so that's going to be quite a big room then. Okay, and he's guessing 5 million. Okay, hmm, I can see that. Now, guys, there's no right or wrong answer, okay? This is just to get you to estimate, okay? Think about how big or how small a ping pong ball is, and think about, how big your room is, and how, how many balls you can fit into the room. Luke said 1 million. Okay. Khalil said 8,000. All right. Look, looking at my room here, it's not a big room. It's like a small bedroom, and I'll reckon that I can fit maybe 1 million at least in the room. So yeah. All right. So that was just a bit of fun for you, just to get you thinking about the problem here. Okay. So let's go on with the lesson. So you guys can download the PowerPoints using these links here. Of course, you also have this in the resource tab as well. Okay. And the textbook chapters are in the resource tab. Okay. But I've also included the questions on the PowerPoint. So if you have the PowerPoints open, you'll be able to see it anyway. All right, so let's open up the PowerPoint. Okay, so our lesson here is raising powers. Okay, so this is still part of year 8 work. We talk about the goal and we've gone through the APK. And here's the notes. Okay, so you guys can write these notes later. Okay, the first piece of notes here, it says that anything, okay, anything except 0 raised to the power of 0 is equal to 1. So there's a few examples here. We've got 4 to the power of 0, that's 1. X to the power of 0 is also 1. And then you have 73xy as a whole group. Okay, that's in brackets, so that is one whole group together. Raised to the power of 0 is 1. Okay, so anything, doesn't matter how complicated it is, as long as it is raised to the power of 0, that will give you an answer of 1. Okay, so let's let's do a couple of example here. Okay, so first we have 4 to the power of 0 plus 2 to the power of 0 plus 3 to the power of 0. Okay, so remember, anything raised to the power of 0 is 1, okay, except for 0. So 4, we have 4 to the power of 0 plus 2 to the power of 0 plus 3 to the power of 0, okay? So each of them is equal to 1, okay? So here we have 1 plus 1 plus 1, and that's going to give you an answer of 3, okay? Next, we have 3a as a whole raised to the power of 0 multiplied by bc as a whole raised to the power of 0 plus 7 to the power of 0. So 3a all to the power of 0 is 1, multiplied by bc all to the power of 0, that's also 1. So we have 1 times 1, and 7 to the power of 0 is 1, so plus 1. Now 1 times 1 is 1, so we have 1 plus 1, and 1 plus 1 is 2. So that's our answer, okay? Then finally we have 5a to the power of 0 plus 6b to the power of 0 c. Now there's a bit of a difference here because you can see that this time we don't have the brackets. So that means that the power of 0 belong to the letter or the number in front of it. Oh, sorry. Yeah, the number or the letter in front of it. So so the first one here, right? This 0 here, this 0 here, that belongs to the a, okay? That's a to the power of 0. And this one belongs to the b, okay? So what you have is, this is 5 times 1, okay? So the 5 is there. It's not affected by the 0. It's not affected by the power of 0 here, okay? And a to the power of 0 is 1. Plus 6, again, that is not affected. So 6 times b to the power of 0, that's 1, times c, okay? So be careful about with this one here. And 5 times 1 is 5, plus 6 times 1 times c, that gives you 6c, okay? And we're just going to leave the answer like this because we cannot simplify this any further, all right? So if you have any questions there, guys, or if you want me to go through anything again, just put it in the chat. Otherwise, we're going to move on, okay? We're going to move on in 10 seconds. All right, so I'm assuming that everyone is okay, and we're just going to move on. The second piece of notes here is that the index law for raising powers says that a power of a power can be simplified by multiplying the indices, okay? So here we have a to the power of m raised to the power of n. So what we do here is we just multiply the powers, okay? So the example here, we've got x to the power of 2, all raised to the power of 5. So we're just going to multiply the powers. So the 2 multiplied by the 5, that's going to give us 10. Okay, so that's going to give us x to the power of 10. Okay. Would anyone like me to explain like why this is the case, or are you guys just okay with knowing the rule here? Okay, Benji, he's okay. All right, I'm just going to move on. Okay. And if anyone is interested, you can ask me later. All right. And I'll show you why. Right, next one is that when an algebraic term is raised to a power, every part of the term is raised to that power. So here I've got a few examples. So if we've got 3x all raised to the power 4, then that's the same as the 3 to the raised to the power 4 and the x raised to the power 4, right? So the power applies to each part of that term. And the second example here, I've got 2y to the power of 3, all raised to the power of 5. So the 5 applies to the 2, so 2 to the power of 5. And the 5 also applies to the y to the power of 3. So here we've got y to the power of 3, all raised to the power of 5. And we just learn how to deal with that, right? So that becomes 2 to the power of 5 and y to the power of 3 times 5. We multiply the powers. So that becomes 2 to the power of 5, y to the power of 15. Okay, now Van says that he needs me to explain this again. So which part, Van? The second one? This one here? Number 3? This one here? So let me go through this again, right? So this power applies to the 2, and it's also applied to the y to the power of 3 here. Okay? So here I'm raising the 2 to the power of 5, and then I'm raising the whole y to the power of 3. Okay? I put that in a bracket, and I'm raising the whole thing to the power of 5. Now, we just learned last slide that when you have a power raised to another power, what you just have to do is you multiply the powers together. Okay? So here we would have 2 to the power of 5 and y to the power of 3 times 5. Okay? And that gives you power of 15. All right. So I'm glad you get it now. So let's move on. Let's try some example here. So we've got first one, 3 to the power of 2, all raised to the power of 6, right? So we're using power of power. So we multiply the powers together, okay? So here is going to be 3 to the power of 2 times 6. And 2 times 6 is 12. So we have 3 to the power of 2 times 3 to the power of 12, okay? And then the second one here, we've got 2a to the power of 5, all of that raised to the power of 3. So what happens is that every part of that bracket is raised to the power of 3 here. So it's 2 to the power of 3, okay? This 3, that's where it comes from. And a to the power of 5, all of that is raised to the power of 3 again, okay? So every part of the bracket gets that power of 3, okay? So 2 to the power of 3, I'm leaving that like that. And I'm just going to open up the brackets for the second part here. So that gives me a to the power of 5 times 3, okay? Which is multiplying the powers here. And that's going to give us an answer of 2 to the power of 3 times a to the power of 15. Okay? Now we can leave the answer like this, or if you want to, you can use your calculator to work out what 2 to the power of 3 is. Okay? And that's 8. Now I'm not asking you to do that because sometimes the number would be too big, right? So just leave it as a power is fine. And then finally here, we've got a to the power of 3, all raised to the power of 4, multiplied by 4a to the power of 5, all raised to the power of 2. Okay, so for this one, it's a combination of the two things, the two boxes that we have here. Okay, so first, I'm going to open up the second bracket. So I have a to the power of 3, all raised to the power of 4. I haven't done anything to that. Multiply by 4 to the power of 2. Okay, so this 2 here applies to the 4, and it applies to the a to the power of 5.
Mister,
Okay, so we have
how did you get the 8A? The 8.
the 8 here for this one.
Yeah.
So 2 to the power of 3 is 2 times 2 times 2. 2 times 2 is 4 times
Oh,
2.
yep, I get it.
Okay, all right. So so back to this third example here. So this is what we have once we're expanding, once we have expanded the brackets. Okay, then we use multiplying the powers. So we have a to the power of 3 times 4 multiplied by 4 to the power of 2 multiplied by a to the power of 5 times 2. And so we have a to the power of 12 multiplied by 4 to the power of 2 multiplied by a to the power of 10. And here I see, oh, we got the same base. And we learn about multiplying powers when it has the same base. We add the powers, right? So we have 4 to the power of 2 multiplied by a to the power of 12 plus 10. And that gives us 16 to the 16a to the power of 22. Okay, so this last part here, this is from last week. Okay, multiplying powers of the same base. So that's for exercise 5K there, and I hope that makes sense. Okay, and there's a video here if you want to watch. All right. Also, like I said, I'm recording the session here, so if you want to listen to this again, you can. Here's the questions, okay, and the due date is this Friday. All right. Now I'm moving on to the next exercise here, guys. So, but if you have any questions, put it in chat and I'll answer that when I can. Okay. All right, moving on here. So this is a bit of an extension, but at the same time, we have done part of this before. Okay, so this lesson is expanding double brackets. Okay, I'm going to go through, we talk about the goal. Okay, and let's talk about this next bit here. Okay, all right, so with this next bit, guys, you know, we're kind of talking, reviewing what we've done with expanding brackets. We have done this before. Okay, so what do you remember about expanding brackets? Okay, 2 minutes, have a think about it. Okay. So at the moment, I haven't seen people putting things in the chat there. So hopefully people are thinking about it. All right.
Mister, isn't it where you go 2 times 4, take away 2 times 3?
Hmm.
Something like that.
Okay. So Van said that you take this outside, multiply by everything inside, right? That's good. That's very good, Van. Okay. So let's move on here. Okay. Um, right. So like Van said, okay, last time when we learned about this, we said that you expand a single bracket by multiplying the term outside by each of the terms inside. Okay. So here, first one, if I got a bracket b plus c close bracket, I just times the a by the c, and then the a by the b, and then times a by the c. Okay. And if I have a bracket b minus c, then I take a multiplied by the b minus a multiplied by the c. Okay. So we've done that, and I hope that that's kind of reminds you about it. So some example here, and I'm going to go through it very quickly because we have done this before. So first one, okay, we take the -2 times by the x, and also the -2 times by the 4. So we have -2 times x minus, now this minus come from here. Okay, so we bring the minus outside. Minus -2 multiplied by the 4. And that's going to give us -2x minus, okay, um, this bit here, we have a negative multiplied by a positive. So that's going to give us a negative answer. And 2 times 4 is 8, right? So we have -8. And because we have two negative, okay, subtracting a negative, that becomes a plus. That's the same as adding. Second one here, again, we take the 5x multiplied by the 4, and then 5x multiplied by the x. So we have 5x times 4 minus, so bring the minus sign out, minus 5x times x, right? 5x times 4 is going to give us 20x, and 5x times x, that gives us 5x squared, okay? And we're going to stop here because we cannot combine them anymore. And then finally, now this one is a bit of a tricky one, so I would like you guys to listen carefully, okay? So we do the same thing. So first we do x multiplied by 5x and x multiply by 1, okay? And the second one we have a negative x, okay, minus.
Mister, haven't we done this?
We have done this, Van. Yes, we did this last time. So this is a bit of a revision
Oh, yeah.
as a bit of an extension, okay? And then this negative x here, you also multiply it by this 3x, okay? So we have x multiplied by 5x. Bring the minus sign out. Then we have x multiplied by 1, okay? Then we have minus, this is where that minus sign comes from. Oh, okay, maybe I'll draw that again. Okay, this minus sign, bring it down, and we have x times 2. And then here we have a minus sign, bring it down. And then we have negative x because we have a negative before, right? Negative x times 3x. Okay, so the tricky bit about this is because all of the negative sign and the minus sign, okay? So that's where it's tricky. All right, so X times 5x give us 5x squared, minus x times 1, which is x, minus x times 2, that gives us 2x, and minus negative x times 3x. So negative times a positive, that gives us a negative answer. And x times 3x give us 3x squared. Since we have two minus sign together, subtracting a negative, that gives us a positive sign. Okay, that's the same as adding. And we can see here that, hey, we've got 5x squared and 3x squared that can be combined together. And the minus x here and a minus 2x that can be combined together. So 5x squared plus 3x squared, that gives us 8x squared. And minus x minus 2x, so it's becoming more negative here. So that's going to give us negative 3x squared. Sorry, negative 3x. Okay. So I hope that makes sense there. All right. The tricky bit, like I said, is all the minus sign. Now, if you feel like you only want to focus on the year 8 skill, so expanding the single brackets here, I am happy for you guys to leave and do your work. Okay. There, so what I would like you to do is to just focus on either the beginner questions or the accomplished questions. Okay. If you would like to stay, then I'm going to go through a bit of the year 9 bit. Okay. It's a bit of an extension here. All right. So I'll give people about 10 seconds to make their decision.
Wait, mister.
Yes, Van?
Is the 5K the year 8 work and then 5K the year
5A
8?
is year 8, and then
Yeah.
5A, this 5A here, this is from the year 10 textbook.
Oh, yep. So do we, the one that we don't need is, the one that we don't need to do is 5A, right?
No, no, you still need to do 5A. You still need to do 5A, but you can choose to do either just the beginner or just the accomplished. Okay?
Oh, yep,
Don't,
okay.
don't do the expert. Does that make sense?
Oh, yep.
Yeah.
For both of them, so like the beginner.
For 5A.
Oh, yep. Okay.
For 5K, it's up to you. All right? All right. So if you are still staying, I'm guessing that you are choosing to learn more. Okay? So here's how we expand double brackets. Okay? So to expand double brackets, you can use what we call the FOIL method. So it says first, so FOIL stand for first, outer, inner, last. Okay? All right. So what that means is, okay, step 1, you multiply the first terms of the brackets. So if we have a look at the picture down on the bottom right corner here, we can see that the um, the first term for the first bracket is x, and the first term for the second one um, is also x. So we multiply those two together. That's going to give us x squared. And then you do the outer. So the outer here are the x and the 5, the one on the outside. So 5x times 5 give us 5x. Then we multiply the inner terms. So 8 and the x here, this 8 and this x. So that's going to give us 8x. And then finally, we multiply the last terms. So here we got the 8 and the 5. So 8 times 5 is 40. Then we see that, hey, the 5x and the 8x can be combined together. That's going to give us 13x. Okay? So this is what we have for this example. So this is the FOIL method. Okay, now there is also another method called the grid method. And basically for the grid method, you draw a grid like this. And for the first bracket, okay, so this x, you write it in here. And the 4, you write it in here. Okay, plus 4. And then for the second bracket, for the second bracket, this x goes here. And this 7 goes here. Okay. And then what you do is you multiply the terms in pairs. So going through the first row, we have x times x, that gives us x squared. Then you have x times 4, that's 4x, yeah? And then we go through the second row. Second row, we got 7 times x, that's 7x. And then 7 times 4, that gives us 28, okay? And then we're just going to combine everything together. So we have x squared plus 4x plus 7x plus 28, okay? And then combine the like terms together. So you can see that they're very similar with each other. It's just, you know, I just find, for me, I find the grid method a better visualization of what's happening. And so I usually use the grid method. But for you, you may feel more comfortable with the foil method. Okay? So it's up to you which method you want to use. Okay? So I hope that makes sense there. So let's go through some example here. So first we got x plus 2 in brackets multiplied by x plus 5 in brackets. So, okay, using the FOIL method. So first, x times x, outer, x times 5, inner, 2 times x, last, 2 times 5. Okay, so then we have x squared plus 5x plus 2x plus 10. Combine the like terms together, we're going to have x squared plus 7x plus 10. Okay? And you can do the same thing using the grid method here. For the second one, we got x minus 2 in brackets squared. Now, remember squared means that it's multiplied by itself. So we have x minus 2 in brackets multiplied by x minus 2 in brackets. Okay, again, using the FOIL. First, x times x, outer, x times negative 2. So the tricky bit here, because we got a plus x, positive x here, that's where the plus come from, times by a negative 2, okay? And then minus, this minus come from here, minus 2 times x, that's the inner. And then for the last, we have minus 2 times minus 2, right? And so we have x squared minus 2x minus 2x minus negative 4. Two negatives together give us a positive. So x squared minus, and combine the like terms together as well. So we have x squared minus 4x plus 4. Okay. The same thing for the grid method. And finally, we have 3x plus 2 in brackets multiplied by 3x minus 2 in brackets. So first, 3x times 3x, outer, 3x times negative 2. Oh, I think I got it the wrong way around there. That's all right. Inner, 2 times 3x, and outer, sorry, last, 2 times negative 2. So we have 3x times 3x is 9x squared. And then we have minus 6x plus 6x minus 4. Now, minus 6x plus 6x. So you have a negative plus the same thing. Okay, they are going to cancel each other. This is the same as when you lose $5 or $6 and then you earn back $6. So basically you haven't lost anything, right? And then so we just have 9x squared minus 4. Okay, and if you use the grid method, this is what you're gonna get. Okay, so I hope that helps you with the double brackets there. Again, like I said, for me, I like the grid method because it showed me I find it easier to work with, especially with negatives. Okay, for the foil, sometimes it can be very tricky to keep track of all the negatives and the minus sign. Okay, so I hope that helps there. Um, Benji, you can just answer as a grid method. Yeah, you definitely can answer as the grid method. Okay, grid method. Although the thing is, you still need to combine it at the end. So here we would write 9x squared plus 6x minus 6x minus 4. Okay, plus 6x minus 6x, that's gone. So we have 9x squared minus 4. So after using the grid, you still have to combine it at the end. Okay? But it should still give you the same answer. Okay? Oh, that's a lot of information there. Okay. So guys, thank you so much for bearing this with me. All right. So this recording will be on Compass for you guys to watch again. Okay. Thanks guys for coming, and yeah, I'll see you and have a good day, guys.